Welcome to ACER Explained. In this video series, I'm going to be going through Section 3 of the new ACER practice test. So if you don't have that booklet in front of you already, go ahead and bring that up because I won't be able to show the questions and the diagrams for copyright reasons. So if you have your booklet, it'll be easier to follow along. So although the booklet is not divided by units per se, it is divided by stimulus. So there's certain questions that are grouped together with the stimulus, and so for the purpose of these videos, I'm going to be calling them Unit 1, 2, 3, etc. So going through Unit 1 first in this video, we're going through questions 1 to 3, and as usual, I'm going to be identifying the prerequisite knowledge that you might need to answer this question, as well as the reasoning skills that you might need to answer this question. And then also I'll be pointing towards some bootcamp resources that you can use as well. So in Unit 1, we're given a table of different mutants of the bacteria Salmonella typhimurium, and we're told whether or not they grow on particular kinds of supplemented mediums. So over here, this is the supplements. Okay, so, and here is the different kinds of mutants. Question 1 is asking us that it's asking indole will build up in the cells of which mutant? Try 1, 2, 3, or 8. So indole is supplemented here. T indicates tryptophan, A indicates anthralic acid, and IgP indicates indole glycerol phosphate. So over here we can see that try 3, when it's not supplemented by anything, it doesn't grow. So it doesn't have the enzymes that are necessary to complete the entire reaction without any supplementation. And that's the same for all of these mutants. None of these mutants can grow without some sort of supplementation. So that's what that means. Then we have T, so tryptophan. When tryptophan is supplemented, all of these can grow, okay? And that gives us a little hint that tryptophan could be at the end of the pathway, because if everything grows when tryptophan is presented, there's likely no other enzymatic step that's after tryptophan that could be impacted by mutations. But that's just, hold on to that thought for a future question. Over here we have indole, and the only ones that can't grow with indole is try 1, 6, and 7. So that essentially means that even when you're supplemented by indole, these mutants lack the enzymes necessary to break it down to whatever step is next. And therefore, there would be a buildup of indole. And so looking over here, we have anthralic acid, and the only thing that can grow with anthralic acid is this one here. The rest cannot grow with anthralic, even if supplemented with anthralic acid. And then IgP, we have another similar thing where these two mutants can't grow even when supplemented with IgP. So that's just interpreting the table there, but in terms of question 1, this was the most important information, and that's how we derive the answer, that try 1 out of these 4 options is going to be the mutant that's going to have a buildup of indole. And now if you still couldn't come to any of this conclusion, what you could have done is a process of elimination and kind of pattern recognition, because when they're asking about indole, so you'd look at this column, and then there's only one odd one out, and that's try 1. And so you could guess in terms of that and then move on. So that's just if you were really struggling with this question. In terms of prerequisite knowledge, you didn't actually need too much prerequisite knowledge. However, it is helpful to know how enzymes work and how metabolic pathways can be disrupted by mutations, and that's just kind of the basic information on enzymes, and so that's something that could be handy. A reasoning skill that we used was the process of elimination. So we went through and we looked at each of the different options, each of the different columns, and took a look at those and figured out which one was the most relevant for us. And the bootcamp resources that can be useful for this are the reasoning skills course, the acceleration class on diagrams and visual stimuli, the acceleration classes on graphs, and then the other one on tables, and the content in action, cells and cellular metabolism for some of that prereq knowledge. Question 2 is asking us about the figure. So the figure is a proposed figure and a proposed pathway to explain the results that were shown in the table. So we have to kind of cross-check these, and the question is asking us whether it's correct or incorrect and the reasoning behind this, right? It's asking what the most valid statement is out of these 4 options. So the diagram is showing anthralic acid becoming IgP, and so there's a step 1 here, there's a step 2 here, and then IgP either becomes tryptophan directly, which is step 4, or it becomes an intermediate indole, which is step 3 here. And so we kind of have a step 3 because there's another pathway involved here. But that's not really entirely relevant for this question. But let's just put it in anyways. We have serine. Okay? So, like I said earlier in the previous question, I said that because all of the mutants can grow on tryptophan supplemented medium, that means tryptophan is likely at the end of the pathway. Because when these mutants have tryptophan, they don't need anything else. They can grow without any other supplementation. And that indicates that there's probably no step here that can be affected by a mutation. Otherwise, at least one of these could be affected. Well, at least one of these would be unable to metabolize tryptophan. So it's likely that this is at the end of the pathway. And this is not always going to be the case because you might have mutants that you haven't created that would affect this extra step, but you just happen to not create them. But for the purpose of just the figure, it actually doesn't contradict what the table is saying. So this part is kind of is assumed to be correct. Okay. Then we have indole, and indole is kind of the next most unaffected mutation. So basically, indole, the only mutants that cannot live on an indole supplemented medium are Tri1, 6, and 7. And that one needs to be supplemented by tryptophan. So it kind of makes sense that indole would be right before tryptophan because it's saying that even though you don't have I, if you have T, that's fine. So it's basically saying like if this step doesn't work, who cares if you can't build tryptophan? It doesn't really matter because you're being supplemented with tryptophan so you can live, right? And so that's why this figure still makes sense. It's not contradicting the table. Then if we take a look at IgP, so IgP is, let's look at Tri3. So Tri3 can grow. Let me bring my eraser out. Okay. So Tri3 can grow when you're supplemented with indole and tryptophan, but if you're only supplemented with IgP, it's not going to grow, which means that there's some sort of disruption here or here. And that kind of goes with this diagram here. See how I'm able to follow along with the table and still match it up to the diagram? There's nothing that's contradicting it. And finally, we have A. And so Tri3, 1, 6, 7, 2, and 4, they all cannot grow if only supplemented with A because they all would have mutations that are impacting this step, or this step. Tri8 can grow when A is supplemented. And it also can grow when IgP, I, and T are supplemented, which means that there's no mutation that's affecting these downstream processes. The mutation is likely affecting step 1. And so see how I was able to follow along and reason through the table using this figure? It doesn't necessarily mean that this figure is the only correct answer, but looking at our answer options, we can say that it's correct because it doesn't contradict table 1. With the other reasonings, you can't use this reasoning because it's not actually explaining why it's correct. It's just saying it's one true thing and another true thing, but it's not actually the reason why this diagram is correct. So you can eliminate option B. And then we also don't have any sufficient reasoning to say that the figure is incorrect either, as we discussed earlier. So the answer is A. Again, it is helpful to know your enzymes and kind of be familiar with the process of metabolic pathways. And the reasoning skills that were used here is interpreting flowcharts. That's quite important, and being able to link that to tables as well as if you were still in a pinch, using the process of elimination. And the bootcamp resources that can help with this are the reasoning skills course, the acceleration classes on diagrams and visual stimuli, graphs, and tables, as well as the content in action on cells and cellular metabolism. Question 3 is asking about the particular mutation in TRI3. So I'm just going to draw out the diagram again, the flow chart. So we have anthralic acid, and there's step 1 here. Step 2 here of anthralic acid becoming IgP. Then IgP either goes to indole to tryptophan, or it goes with adding serine. And this here is step 3, and this here is step 4. All right, so TRI3 cannot grow when supplemented with nothing. So it needs to be supplemented with one of these 4 in order to grow. When it's supplemented with T, it can grow with tryptophan. When it's supplemented with indole, it can grow. And so that's important. So if T is here and it's supplemented with T, that kind of makes sense. It's at the end of the pathway. All of our mutants can grow when they're supplemented with T, so that doesn't really tell us much. But when it's supplemented with I only, so no T, only I, it can also grow. And that shows us that step 4 is working, because I is able to be converted to T, which is then able to be used in whatever, whatever biological use it has. So that's important. So we can say that step 4 is not impacted. Then we have A. It cannot grow when supplemented with just A. So this is when it's only supplemented with anthralic acid, it doesn't grow. Okay? And so that means that there's a mutant. The mutation is impacting a step that's downstream from A, because something is unable to either convert it to IgP or convert IgP to I, which is causing a buildup in this metabolic pathway and blocking the pathway from fully reaching the end, right? So that means we can eliminate step 1 because there's likely it's impacting a downstream process, a downstream step from A. Then we have IgP, and it cannot grow when given only IgP as well. And so basically, just going to change my color. So IgP, when you give it only IgP, it cannot be converted into I, or I cannot be converted to T. So that's downstream of IgP. Now we already know that when supplemented with I, it can be converted to T. So step 4 is working, and the only step here that can be affected is step 3. And so step 3 is your answer. So it's quite important to kind of understand how flowcharts work in this case, and understanding downstream versus upstream effects, and being able to decipher whether or not certain interruptions to the flowchart or whatever it may be is going to impact XYZ process downstream or upstream, and being able to kind of reason through that. That's the skill that was required here. So with this question, you didn't really need any prerequisite knowledge, because it's basically just asking you to believe figure one, and it's not asking you to kind of figure out anything in particular in terms of like a metabolic pathway, but it is asking you to reason with that flowchart in mind. And so you don't need any prerequisite knowledge there, but the reasoning skills that you did need to use was interpreting flowcharts and being able to link that back to tables, as well as using the process of elimination that we did there, eliminating the incorrect options first. And the bootcamp resources are the same ones that I've been mentioning so far in this video. And that brings us to the end of Unit 1. So please like, share, and subscribe for more GAMSAT help. We really appreciate your feedback and would love to take it on. We have our Instagram at Thank Flip GAMSAT, and our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT, if you want to hear more from us. I'll see you in the next one.